Hello everyone. Do you hear me okay? Yeah? You hear me okay? Everyone? Okay. So, last time we started talking about how everything in a computer is represented by a set of binaries, binary numbers. So everything gets translated to a bunch of zeros and ones, including a number, a character, or a color, and like a pixel color in an image. So, for example, here every information is encoded like that with this binary number. So if you see this binary number, you might have wondered, like, how can a computer know that, interpret this binary number as being representing of a decimal number 72, or a character, like a character uppercase H, or a color in an image. And that's how we use encoding formats. So every time you store a folder, for a file, for example, in your computer, you store it with a specific extension, right? Like a .pdf, .jpeg, .txt, and these extensions mean something. Meaning that whatever it's stored, like that's for that file, whatever you are seeing, like the text that you are seeing in your file, in your text file, will get translated into a bunch of zeros and ones. But since it's stored with a .txt extension, I know that every time I open that file, the program will load it, and these zeros and ones actually that was stored in the computer will get translated into actual characters and emojis and stuff like that. So that's why it's really important for every single file to have an extension that will represent the encoding of the information that it's in, that's in there. So far, so good? All right. Now, this part is optional. I'm not going to go through it in too much detail, but from now on, every time you see something said optional in the slides, meaning these are like extra stuff to need to see if you are curious to know about them, to learn about them, but I'm not going to ask you questions about it. But if you want to know like how, for example, a computer will store every number that, for example, that you write. Let's say I'm writing variable a and say a is equal to 1020. You, by default, actually, a computer will have a specific set of space located somewhere in memory that will help you store this information. Now, I'm going a little bit fast here, but just you can go through them if you are curious to know. Something also that important to do in your to-do list is installing Thonny. This is a special software available for free that I'll be using to write code into it. But if you are familiar with another tool that will, if you're already programmed in Python, you know about another tool. I'll be talking about this later on. But if you're like, you don't know what to install yet, download this. You can follow along with me as I'm writing code. I'll be writing code on Thonny in class, so you can follow along. Okay. Now, going to lecture 2, and that's today's lecture. Before I do so, now all of you have access on Ed. If you don't, let me know. But you probably by now on Ed, you will be seeing this tutorial here. Again, a reminder, this is a space for you to practice. So you have like a lot of questions in this tutorial 1 on base conversion. So converting from binary to decimal, or from base 5 to decimal, or whatever. So it's a great opportunity for you to practice. You can submit it. I mean, it's not graded. I'm not going to track you down or whatever. It's just a space for you to practice. And actually, starting next week, TAs will be animating tutorials. So there will be a tutorial on Monday and another one on Wednesday, if the Monday one doesn't fit within your schedule. So the TAs will pick some of these questions and they go through them and they will show you their process and go into the solution. The solution is going to be always ready, available by the end of each week. So right now, maybe the tutorial, if you try to do it, you can try right now to do it. It's a great way to start practicing and getting ready for the first section that we saw in class. Any questions related to this? No? Okay. All right. Now moving on to the second lecture, which is our today's topic, programming with Python. Now, somebody, I think in this section, or I don't know if this section or the other one, I showed you how we can convert from binary to decimal, or from any base to a decimal number. So again, a decimal number, this is base 10. That's where how we use or we describe numbers, let's say. That's the numeral system that we will use when I say, like, there are 200 students in this class or 235 students in this class. You know what I'm talking about. And decimal number, because we use the base 10 because most of us human beings have 10 fingers, and that's the base. But a computer will use a binary number representation, and that's every single number will get represented by either 0 or 1. Now, last time I showed you how to go from a decimal number if you want to convert the decimal number into binary. So if I write the number 235, how is it going to be represented for a computer? Let's say if they want to store that number, they need to translate it into a binary number. And the trick to go from decimal to binary is what? How can I convert a number from decimal to binary? Any idea? Do you remember? Yeah? Exactly. Divided by the base. So if I'm going to decimal to base 2, I'll divide by 2 and keep track of the remainder. Some of you, I don't know who asked me about, like, what's the intuition behind it, and this is me trying to explain to you the intuition behind this. This is, again, just in case you want to, like, understand why this magic is working, the fact that I'm dividing by 2 is working. And again, I put a lot of some of the links that I found out that maybe help you understand better the intuition behind it. Now, let me start with the first question for you. And again, as a reminder, we'll be using Slido a lot, and I'm not going to track you down when I use Slido. It's just for me to get feedback from you and make the course a little bit more interactive and less boring, hopefully. So, if you see these bunch of binary numbers, try to select which of these numbers are even numbers, are representing an even number. Okay, let me take a look. You can continue answering the quiz. Alright, so majority are saying the 2 numbers here. Some of you are saying these 2 numbers. Alright. Now, the trick here, this is something that, I mean, maybe some of you tried, like, started computing. And do you remember how to compute? If I give you a binary number, how to convert that binary number into a decimal number? What's the trick here? Anybody?
2 to the 0, 2 to the 1.
Exactly. Multiplying these digits. So, if you look, the trick, for example, if to convert any binary number into decimal is to take every single digit, taking the first one from the right side, and multiply it by 2 to the power of 0. This is like the first position. Then plus this one times 2 to the power of 1, plus this one times 2 to the power of 2, etc. Now, 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. All of these are even numbers. So if I sum them up, I know it's going to lead to an even number. The only digit that will make me decide whether it's going to be an even number or odd number is the first one. So if I have a 0, the digit value is 0 in there, so I'm multiplying 0 times 2 to the power of 1, 0 times 2 to the power of 0, which is 0, plus a bunch of even numbers. And a bunch of even numbers will lead to an even number. But if this digit here like in this one, ends with a 1, I'll be multiplying 1 times 2 to the power of 0. 1 times 2 to the power of 0 is 1, and I'm adding 1 plus a bunch of even numbers, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. These are all even numbers, and I'm adding a plus 1 to them. That will lead to an odd number. Make sense? Should I re-explain it more in details? Or no? Okay. So, as a rule, keep it as a rule, if I give you any binary number, you don't even have to like convert it into a decimal number. If you see that the first digit that you see in here is 1, that means that for sure it's representing an odd number. If you see a 0 in here, that means it's representing an even number. It's just a trick for you. So maybe if I ask you a question on a midterm and say, okay, what is the representation of the number 84 in binary, you know that 84 is an even number. So if I try to convert that number to binary and I realize that the binary number ends with 1, I probably made a mistake somewhere. And it's going to help you like say, okay, this is probably not the correct solution that I should pick. Make sense? Okay. Now, with that in mind, this is a question that I asked. Let me show you the slide. I think it's better with the slide. Here. This question I asked with ChatGPT 3.5, so the old version of GPT. I didn't try it with the new version right now, but this is like, let's say it's going to lead to the same result. I asked it the following question. What is the decimal representation of this big binary number? And the answer was, the decimal representation of this number is 2064. In your opinion, and you can answer on the Slido, is this answer correct or not? Did the GPT algorithm made a mistake or not? Okay, let's take a look. All right. Majority is saying no. Some of you are saying, what is ChatGPT? And some of you are saying yes. So, if you said no, why is that? Yeah?
That's like 2 to the 15th power. That's way bigger than 26.
Okay, continue. Sorry, can you repeat?
One of those, that's like, one of those ones is like 2 to the 14th or 15th power. And so if you're multiplying 1 by 2 to the 15, that's much, much bigger than 26.
Okay, that's one way of looking at it. Is there like an easier shortcut? Yeah?
It's also the odd and even thing you just said.
Yeah, it's the thing of the odd and even also. But it's a good, interesting idea. I didn't think of like the 2 to the 15 answer. But here, the binary number ends with 1. That means it's representing an odd decimal number. And 2064 is an even number. So the answer is not correct for sure. Now, if you're wondering what is ChatGPT, that's okay. It's like a chat bot online where you can ask it a question, give you answer. Now, I know some of you are tempted to use ChatGPT or any other similar lure. There are a lot of chatbots, like very smart ones, very, very smart ones, right? They can give you any answer, like a programming answer, question, or anything. Now, these tools actually, they are like part of a, so ChatGPT is one of these models that was designed by a company called OpenAI, and it relies on a model, part of a family of models called large language models. And how they work is just kind of like a child. You give it a lot of example and say like, this is how the word works. Now you can answer questions. So ChatGPT, for example, the GPT for whatever number that we have to now, we give them a lot of information about the word. So give them like a lot of examples of research papers or Reddit posts, like Stack Overflow posts, stuff like that. and tell them, hey, this is all the information, take a look at this, and now every time I ask you a question, you can, like, from whatever you learned before, try to give me the answer. So something that you have to be careful about is that these tools might be biased. Pretty sure they are biased, because they relies on information that is, by default, could be biased also. Second thing is that doesn't necessarily guarantee that they are giving you correct answers. So models like GPT, for example, there are others that are much better, but GPT, for example, they are not good at computing stuff. So when you are asking them for binary conversion, they're not applying the algorithm, whatever. They're just, how they work, it's like just about the language, just about a model. And I always give this example I found online, is that, we've been used to hearing the song Happy Birthday to You over and over again. So you heard it thousands of times by now. So if I say happy birthday, you know that if I want to fill out this sentence, you just have to say to you. That's the statistically speaking, you've seen happy birthday to you so many times that if I give you the two first words, you know how to finish the sentence, right? I don't need to do that. That's how ChatGPT or these models works. I give them a lot of information, and they know that after the word happy and the word birthday, I have to put the word to you and not to the sun or whatever. So it's not really understanding whatever they're typing. It's just like filling out a bunch of formula based on whatever they learned. So they are doing amazing stuff. I agree with you on that, but I want you also to be careful when you use them. You might be tempted to rely on them, but be careful. Any work submitted in this course should not be done by these tools. And if you check on the syllabus, I might even select some students at the end of each assignment and ask them to, me or one of the TAs will ask you to explain your code, for example, or to give like a kind of an oral interview to explain your thinking or behind whatever code you wrote. So, and sometimes they can lead you to mistakes. So be careful with these tools. Second thing, you might use it, for example, to understand certain topics that we are covering here, or maybe they can be helpful giving you examples or explaining things, or, but be careful with the answer that you got. And in Come to I want you to understand code and be able to debug it and learn it by yourself, so that later on, maybe in the future, you'll be relying on tools like ChatGPT, but you know now that you have the ability and the knowledge, necessary knowledge, that if ChatGPT gives you an answer, you know how to judge that answer. Is it a correct one, or they're leading me to a mistake like this one? Make sense? All right, cool. Now, last time I showed you this slide and told you that computer science is about more than coding, right? But in the context of this class, we will be focusing a lot about the coding part of the computer science. Now, the first question that we need to ask ourselves is, what is programming? Or more first, what is an algorithm? We use the word algorithm and program interchangeably as if they are synonyms, but technically there's a small difference between the two. Now, if you look at the definition of an algorithm, it is a step-by-step procedure for solving a problem or accomplishing some end. What I mean by that is that an example of an algorithm could be a recipe. A recipe is a set of instructions, step-by-step, organized in specific order, and the order is really important, right? You have to, mix the ingredients before putting it into the oven and not the other way around, right? So the order is really important, and the steps are really clear, and that's what constitutes an algorithm. Another idea is an assembly instructions. You have to follow them in a specific order also, and that constitutes an algorithm. In computer science, for example, if you read research papers, usually we would represent, so scientists will define a new idea of, for example, here it was an old paper where it used to detect fake users on Twitter. Now it became X, used to be Twitter. And scientists will not copy-paste their code. They don't show the code in their papers. They will actually translate their code into algorithm. They will share the algorithm version of their code like this. So it looks like written in English, some mathematical operations, but it's easier for anybody to read. This is because I can translate this algorithm into different programming languages. So the algorithm will show you the logic, the idea, how to go step by step, and then the program that you will have to write. You can write it in Python or in C++. They will all follow the same algorithm, for example, but they will use different language. That's it. Now, another way in computer science to represent algorithms is using flowcharts. This is something I might ask you, and for the first assignment is that I'll give you a challenge, and I tell you, okay, I want you to design the flowchart, how to solve it, so step by step, and then translate that flowchart into actual code in Python. So you will know for sure that the word algorithm and the word program are different a little bit. Now this is an example of a flowchart for making tea. And you see there are like special symbols. These two symbols are called the terminator, say when I should start, when I should stop. And then there are processes. So everything in a rectangle saying like this is one step, second step, and there are like arrows to link the flow, so it'll tell you where I should go next after each step. A diamond shape symbol here say, so to make the tea I have to start, fill the kettle, heat the water, and wait for the water to boil. So if the water didn't boil, I have to wait more. So that's why like I have this kind of loop. And this diamond shape will express usually a condition or a question that you have to ask, and it ends with a yes or no kind of questions. And if it has boiled, then I can start making my tea, and I'll stop there. So this is an example of a flowchart. Now, another example, of a flowchart is TikTok algorithm. I mean, it is a well-kept secret. I'm not sharing you the secret of TikTok and how they work, but this is just somebody actually tried to think about like how probably the TikTok algorithm might work. So, for example, somebody will post a video, and it will have like an initial push. It will be pushed to viewers, and there will be a performance rating that will be computed based on the completion ratio, the number of shares, the number of comments, the number of likes. And that's how TikTok will decide, okay, does the performance, is it higher or lower in a specific threshold? If it's higher, that means that it might be a popular video to keep pushing to other people. And that's why I want you to understand why you see sometimes certain posts on TikTok or Instagram or something versus others. Because these algorithms, they make the decision for us. It's not because I'm necessarily I wanted to see, or it's really important for me to see this video. It's just like they made this decision. So this is a flowchart that will represent how the TikTok algorithm would work. Now, my question for you as a group, it could be a group of 5 or more or less, is to design your own flowcharts of how you would go to university, from waking up to showing up on campus. So you can be as creative as you want and make different decisions as long as you use these symbols. So remember, I told you your job in university is to also network. So it's an opportunity for you to introduce yourself to the people sitting next to you and start working on this. I might select 2 people that will write their flowchart on the blackboard. If there are any volunteers, you can raise your hand. Otherwise, I'll pick myself, whoever. All right, I'll give you a few minutes. Now you can talk together.
So, that's up. That's me.
So this one, how do you guys work? Make breakfast, eat breakfast, and drink coffee. Yeah, yeah, yeah. Yeah. So that, oh, that's tired or no coffee. That, you can make that one. So we would have 13. Would we make coffee?
So the next tab is going to be need to check what is it.
No, that so yes, would we make coffee or have a coffee? No, would just be when I was yeah, just make a menu and or get ready to move better. Yeah. Okay. So then we start, yeah. Another yes one. And then safely get ready. So down to know we get ready. I feel like good job, guys.
Perfect. Thank you, guys. All right. Okay, hope that you had much fun doing this practice. All right, so thanks for the two teams who agreed on doing this on the blackboard. And like I said, like there's technically no wrong answer in there. It's just like maybe in terms of symbols we have to be careful about. So for example, on here, start, wake up, ask yourself, are you hungry? Yes, I will eat. No, put on some clothes. It would be best to put like action verbs in there, so it would be easier to understand, but makes sense. Okay, then pack, leave, walk, McGill, and then stop. Okay, so that's one of the suggested process. The other one, wake up tired, yes, have coffee, no, hungry, and if I have coffee, so you'll have coffee no matter what, breakfast. Okay, so if I'm hungry, yes, I'll take breakfast, otherwise I'll get ready. After breakfast, I'll get ready also, commute, and then class. Okay, so usually wake up and get to class would put them into a process here, like this. But technically it's correct. It's just like a rule that we will be putting between us in the context of this course. The terminator is going to be called start and stop. And then the others are like processes, right? Like there's action happening in there. So we'll put start here and stop. So one start and one stop and stuff happening in between. Some of you might wonder, like, what does this input-output thing means? You will see later when we will start designing flowcharts, for example, in the assignment. Every time you are interacting with the user, for example, asking them a question, what's your name? Or showing them a message, like, I don't know, the result is blah, blah, blah. This will be written inside a parallelogram. So every time you are interacting, that's when you will use this symbol. Otherwise, most of them are like going to be processes. Every time you do a computation, you'll do like an action. This is going to be a process. Now, I want to also, what I like about this exercise is that probably all of you have some kind of version like this. You have it in you. You don't need to, like, I just showed you this a few seconds ago and you are figuring it out by yourself. You're able to design the flowchart, right? So the main idea is that this programming, this is what about like algorithmic thinking, how to process things step by step in a specific order. And I'm pretty sure all of you already have these instincts within you. Now the product or the objective this semester is to practice this muscle more and more. But you have it already, which is great. The second thing that I realized is that I've been giving this exercise, I don't know how many times so far, how many semesters. And this is the first semester ever. No one thought about the snooze button. What's happening with you guys? Like, you wake up fresh. I mean, good for you. Maybe 2025 is your year, and but I don't know. Like most students will think like first snooze. Should I snooze or not? But all right. So what else I wanted to say? So yeah. So that's the idea about flowcharts. It's organizing the processes in a specific manner, respecting these symbols. These are the only ones that you have to know about. And then now you wrote an algorithm. You can translate that algorithm into code. And you have like an actual code written in Python or C++ or Java or whatever programming language. This is an extra fun to watch if you know Big Bang Theory TV show. There's like where they design a flowchart on the friendship algorithm, if you want to take a look. I'm not going to ask you questions about it, it's just for you. Now that you know what is an algorithm, when I say the word a program is actually the translation of that algorithm into code, into a programming language. So, and there are different programming languages, Java, Python, C++, etc. And usually when you write code into using a programming languages, the structure is really important. When you write using like algorithms like this, it can be more or less, we are not going to be picky about the words that you will be using. Maybe the symbols are important, but that's it. But when you are writing code, programs are very picky. And you don't forget that when you are writing program, deep down what you are doing, you are interacting with the computer. We are telling them, okay, I want you to compute this. I want you to show me this. I want you to ask this question, etc. And you have to follow a certain structure because that's the only structure that a computer would understand. Now, in terms of programming languages, there are actually, these are like formal languages designed to communicate instructions to a computer. And there are two families, let's say, of programming languages. Low-level languages, these are like language spoken by the computer or closer to the computer actually. Remember that computer uses binary, right, to understand the word, understand everything, any information. And the other family is high-level languages. So these are programming languages that use English and mathematical operations and symbols to communicate instructions. So Python is a high-level language, Java is a high-level language. Most of the programming language that you will have to learn if you're in computer science are going to be high-level languages. Now, if we take a look at the first family, low-level languages, there are two categories within that family. Machine language, which is directly understood by the computer. It needs no translation, so it's a bunch of zeros and ones. Only the computer will understand what does this means, and it will apply it. And the other category is assembly language. It's a little bit like another extra layer between machine code and assembly language. It's like easier for a human to understand, but still pretty much hard. It's not very obvious to learn assembly. Some of you, or if you are like majoring in computer science, you might need to take a course where they will show you how to write code in assembly. But the structure of assembly language is something like this. So it will use like special words in English, but it's really hard to write code in them. But you are still getting closer to the machine. Now, programs written in low-level languages are hardware specific, meaning if I write a code on my machine, I cannot share it with you, and it's not going to work on your machine. And that's why they are like closer to the machine itself, so I cannot share it with other people using different hardware. On the other hand, high-level languages are easier to read and easier to program, so easier to learn how to program using these high-level languages. And programs in high-level languages are called portable. So the word portable means that if I write a code in Python or Java, I can share it with all of you. No matter what computer you are using, you'll be able to run that same code. So that's the main difference between high-level and low-level languages. And so they can run on different kinds of computer, and that's why usually people will share online high-level languages code, right? How do computers understand the high-level languages? Actually, these languages are going to be translated. So it's just like a layer for us, human beings, to be able to give instructions to the computer, but deep down the computer is still understanding them as a bunch of zeros and ones. And there are two special translators that will be in charge of this translation from Python code or Java code into machine code, a bunch of zeros and ones. These two translators, one of them is called compiler, the other is called an interpreter. And so, for example, a programming language like C++ uses a compiler. What it means is that I will write in a file, in a C++ file, my code, saying like, I want you to compute A plus B and display the result. So I will write my code, and then I'll have to compile my code. I will call a compiler, a C++ compiler, that will translate my instructions into a bunch of zeros and ones. In the end, it will give me back an executable file, a file with a .exe extension. And that file, if I click on it, now I'll see my instruction being run. So I will see the computation of A plus B, and I will see the result being displayed in front of me. So like two steps when you use a language like C++, or if you have already, anybody wrote code in C++ here? Yeah? All right. So you know how it is. It goes two steps. You have to compile it. If you compile it, you can go to the next step. Otherwise, you cannot run your code. The great thing is that once compiled, the program can be run over and over again without needing to be retranslated again. And usually, programming languages like C++ are very, very fast to compute things because of this, and like the run execution time is way, way faster. Now, the interpreted languages, so for example, Python is an interpreted language. It uses an interpreter to translate the code into machine code. And the interpreter works differently than a compiler. The compiler, you give it the file, the entire file, it will compile the entire file and give you an executable. An interpreter, you give it the file, and it will interpret the lines line by line as you go. So first line, I will convert it into machine code, and I will see the result. So if I want to compute A plus B, from the first line, it will say to the computer, I want you to compute A plus B in binary, and I will see the result as they go. So it goes line by line, and the interpreter goes as we go through the program. So it translates on the fly. and there is no object code, no executable. It's just one step. It's like as if it's compiling, it's translating, and showing me the result as we go, faster. The only thing is that if you want to run code again, you need to run the interpreter again. So it can be time-consuming this way, but it's nicer sometimes to have like an interpreted language, because you can see the result as we go faster. All right, so these are like the two tools. So interpreters and compilers. So languages like C++ will use a compiler. Languages like Python is an interpreted language, so it uses an interpreter. Now, what is programming in Python? Python is a widely used high-level programming language, and it is an interpreted language, like I said. And there are many interpreters actually in Python. The advantages is that it's easy and it has a concise syntax. It has lots of built-in functionality that are free and open source. Now in this course, sometimes I'll put certain restrictions. You will realize certain restrictions for the assignments, because I want you to use, for example, a specific function. I want you to create your own version of that function, because I want you to learn how to program. So later on, if you move on to another programming language, you'll be able to handle it, right? No matter what language. And it is the Swiss Army knife of programming. It can be used to create pretty much any application. Now, my question for you is, do you know why it's called Python? Not this one. All right, is it because of a family of snakes, or comedy troupe, or because of an acronym of some sort? All right, you can continue. I'll take a look. All right, majority are saying acronym, some are saying comedy troupe, and few of you are saying family of snakes. And the correct answer, drum roll, because of a comedy troupe. And yeah, so because of these guys. So the person behind the first version of Python, the person who created the Python programming language, is called Guido van Rossum. He comes from the Netherlands. And back in the 70s, when he thought about like this Python new programming language, the Monty Python, this is the comedy troupe that have like a lot of success. Do you know about SNL? Saturday Night Live? Yeah. So they're like as big as Saturday Night Live back in the day. And they have a lot of funny sketches. And they had like a big influence back on at that day. And that's why, because he was a big fan, I guess, he decided to name his programming language because of these guys, as an homage, if you want to. And actually, they have a lot of influence. So if you know, like the word spam that we use for like these kind of strange emails, annoying emails that we get sometimes, the word spam comes from a sketch from these guys. So if you can type Monty Python spam, it's like they have a sketch where they use the word spam over and over again, and then the community decided to name any undesired email the word spam. That's it. So they have a big influence in computer science for whatever reason, because people like them, I guess. And they are pretty funny, so take a look at them. All right. Again, I'm not going to ask you a question about like why is it called Python, just for you, like make it fun, okay? Now, when we start writing a program in Python, actually a program can be written in any text editor. I can even use like a simple TXT editor, like Notepad or something, to write my code, and I can run it. But there are like more advanced text editors like Sublime, Emacs, that will help you also write code. So you just need to write your code on some sort of file, and you just need to call the interpreter that will translate that file, everything that you wrote in that file as a Python instructions, and we're able to understand it and give it to the computer. The second option is using what we call an integrated development environment. These are like special software that you can download, and it will make coding much way easier than writing in a simple text file. So, for example, Thonny is one of them. So during this semester, I'll be using a software. It's available for free, and it's actually designed from someone from Estonia, I think. And it's meant for teaching, actually, purposes and teaching and learning purposes. But there are other IDEs, if you know them, like, for example, PyCharm, Visual Studio. I know, like, a lot of people usually, when they write code in industry, let's say, is either PyCharm or Visual Studio. I mean, that's what I know about, at least. But there are many, many more. So an IDE is a kind of a special software where you can write code. But I want you to know is that I don't necessarily need an IDE as long as I have the interpreter, Python interpreter, installed in my computer. And usually most nowadays computers, Python is already, the interpreter is already in there. And if not, you just have to download it and install it. And these IDEs make programming much easier. And that's why we use them. So they have syntax highlighting. They sometimes even complete the code for you. And you can run the code directly and see the results as you write it. And they have debugging tools. Now, don't forget is that programming is not just like writing code from scratch and that's it. It's just sometimes you have a code and you have to debug it. Like try to understand it, locate if there is an error, and try to find an error. There are tools actually with these IDEs that will help you debug code and run line by line and try to locate where the issue is from. All right. Now, if I open Thonny for the first time, or any IDE, usually, so for example in Thonny, and that's the IDE that I'll be using, like I said, in this semester, there are two main parts. Ignore these two. Like, I can close them if you want. Okay. There's two main parts, a text editor and a shell. Now, a text editor, it's like any Notepad or any TXT editor. I just write whatever I want, but usually it must be code in Python. The shell here has two purposes. First, you can use it as a simple calculator or to test stuff very quickly, or it will help you actually write your code in the text editor, run it, and you will see the results showing up in the shell. So the shell will give you back what the computer is. Did it understand your instructions or not? So to display the results. Now, like I said, in shell, you can use it to do any calculation. So, for example, I can say 7 plus 3. I can even define variables a equal to 7, b equal to 3, and then say c equal to a plus b. And then I can click C and hit enter, and I will be seeing the value of C, the computed value of C. So I see C is the result of a plus b. Would that make sense? Does this order make sense, or would it work if I say C is equal to A plus B before defining a value of A and B? No, right? So the order of instruction is really important. I have to define a value for A, a value for B in order to compute the sum. So this is one algorithm, a tiny one, but it's one algorithm, step by step. I mean, it's written in code, so it's like a program, a small, short program, if you want. Now, if you technically in any assignment or technically you usually write code in the text editor, and that's how when you write your code in a text editor, inside this text editor, you'll be able to store it so that if you close your computer, you'll be able to reopen that file again and see what you typed. So in order to, this is like the file that was opened for me by default. Sorry about that. But I can create, by clicking here, I can create a new file. I can create as many files as I want. Or I can click here, File, New. Both of them will lead to the same result. Now, if there are certain rules about the file names. So every time you create a file, you have to give it a name. And usually we'll use lowercase character, alphabetical characters, maybe a number at the end of the file name. It doesn't technically ideal not start with a number. And don't use any special characters. So no exclamation point, no question mark, no dollar signs as a name of a file. You can only use the underscore. For example, if I want to call my file, I can say my file or my underscore file. Now, let's say I want to write in a new file, so I will be creating, let me close it. No. I'm creating a new file, and first thing, I'm gonna save it. So I can click here, save, or I can say, I click, for example, my shortcut is Command Save. Maybe use Control Save for you. And I'm gonna save it, and I'm gonna give it a name. I'm going to call it hello.py. So this is the first of my, the name of my file, hello.py. So py is the Python extension saying like this is a Python file. And it is located on my desktop. If you look at my desktop here, I have this file hello.py that was created. So it's stored there. I keep it forever if I want to. Now the first program is I want to write this line, print hello world. So let me click here, hello world. Okay. Now, don't forget every time you write something on your file is to make sure that you save it as you go, because sometimes the computer will shut down for whatever reason. You might lose whatever you wrote in here. So make sure that you save any changes that you made to your file. Now in here I made this new line. What I'm doing here, you see that I'm asking, you see that print is colored in special color, saying this is a special keyword in Python. And this is something that the interpreter will understand as me asking the computer to display something for me. And the parentheses are important, saying this is actually the special keyword called print. It's actually a function. It's a function that will do something for me. And that something is just displaying the word hello world. Now, if I want to run this, so this is me writing my instructions, and if I want to see if the computer is understanding my instructions, I can click on this button here. So if I say run current script by clicking here, or you can click run, both of them will do the exact same thing. If I click here, I will see the message hello world. So that means that the computer understood my instructions. They are showing me literally this hello world. So far so good? Everything that you might have realized that I'm like, whatever, the quotation marks are not part of the message. This is part of the syntax. So I'm saying I want you to print literally these characters. And the quotation marks saying like, whatever you see between these quotation marks, I want you to show them as they are. And the computer is not going to understand that you are writing the word, like it's not going to understand that you are saying the word hello and the word word. Like they are not interpreting the language. They are just saying, okay, you want me to display uppercase H and lowercase e and lowercase l and lowercase l, another one, etc. So that's all. It's going to display it as it is. That's it. I can even add an exclamation point if I want to. It's going to change. So now I see hello word with an exclamation point. In Python, I can put the text that I want to display between double quotation marks or single ones. Python will accept both. So I can do it this way also, and it will lead to exact same result. So that's about the print statement. Now, yeah. So this is what we call print is a function. It will display. And hello world is the message that I want to display. And this is our first Python statement. It's an instruction. It's a line of code that performs a basic specific operation. Now, if I take this file, so here you see that I was able to run this file, run the file hello.py, and see the result showing up in the shell here, showing me if the computer interpreted was able to understand my instructions. I want to see the word hello word, and the computer was able to understand it and showing me the hello word message. Now this is through Thonny. But like I said, we don't necessarily need an IDE like Thonny to run code. So if you look at the file hello.py that I have in here, actually I can even open it with a text editor if I want to. I will see this just here, hello world. It's like just a bunch of text. I don't see any color coding anymore because it's just considering like a bunch of characters that being printed. There's no interpretation behind it. But now, because of this file that has instructions written in Python, I actually can run it in a different way. And this way is using the terminal or the command line. So if I click on terminal on my Mac, I know that hello, this file was stored inside a desk. Like if you see here, or maybe let me open it. So you see that the hello.py is stored inside a file called desktop, in a folder, called desktop. So I can, for example, using the terminal. A terminal is another way to communicate information. So in computers like Mac or Windows computer, they have like these kind of intelligent graphical interface that will help me interact with the computer, for example, navigate through files, etc. I can do it this way, or I can use it through just talking directly to the computer, and I say, I want you to change directory. So CD is for change directory. I want you to go to the directory called desktop. Now I'm inside the directory called desktop, and inside the directory called desktop, I have the file hello.py. Now I know that it's inside. I can just call, so here when I say Python 3, I'm actually calling the Python interpreter and saying, okay, I have a file called hello.py. I want you to interpret this, and ask the computer to do whatever instructions I'm writing inside. And if I click enter, as a result, I'll see the hello word being displayed. Now, this part that I'm showing here, this is optional. No need to worry about it. You can, like, there are more classes that will you need to take maybe in order to know more about like the command line, or you can learn on your own if you want to. But this is just an example to show you that I don't necessarily need a program like Thonny or PyCharm or whatever to run a code. I can just use it this way also. And this is the terminal. Like every single computer has a terminal, or the command line if you are in Windows, or something similar. I don't know, remember the name if you are in Linux. All right, now going back to Thonny, but now don't get scared. It's just optional material. Just I want to show you that this is actually possible. But from now on, we'll be using Thonny or any other tool that you want to do. Now, going back to our code. So far, this code, if I run it, I'll see hello world over and over again. I keep running it over and over again, and you'll see like it is running the file called hello.py. Now, something that I can add also is called comments. So anything that will start with the hashtag in Python like this is called a comment. Everything that you see here in gray will be actually completely ignored by the interpreter and by the computer. It's not an instruction for the computer. It's usually meant for another human being. So usually in a comment we'll write like, this is a program that will say hello. So a comment, anything that you see in gray in here, is completely ignored by the computer. It's mainly meant for another human being to read. And like I said, usually when we write code, it's meant for, usually write code in teams. We are a team of people working together on a program. We'll have like different files interacting with each other. And comments are good standard, good behavior for you to learn as a programmer. Sometimes you will be annoyed with me by me asking you to comment your code, but it's a great practice. Because you have to think about, like, later on, maybe you will be part of a team and you have to share your program with the rest of the world, or I don't know, someone who mentioned like they want to make their GitHub account better last time. This also, like, you want to share your code, you want to make it easier also for another fellow coder to understand your code. So comments are a great way to do so. You don't need to put a line for every single instruction that you will write in your code, but usually you will learn about, with experience, with time, you will learn how to and when to write comments. So for example, for me, when I started at the NRC, I had to be part of like a team of, I think, 20 people or so, and they had already the program, a first version of the program that was like a software, like the VitalSeal one, the one, if you remember last time I showed you, like the one where we were computing measurements, heart rate measurements, and SpO2 levels just by using the web camera. So the software was there. And like there are thousands of lines of code. Some of it's written in Python, some of it's written in C++. And they tell me, hey, welcome to the team. Fat and I want you to change certain features in this code. Good luck. And I had to go through this, like these lines of code, thousands of lines of code. And some of them were not commented. And it was really a mess. It took me a little bit of a while to understand and to know what to actually do with it. So please be nice to another fellow human being in the future and write comments. So again, if I write a comment, you will see that it doesn't impact anything to my code. If I run it, still say hello word. It's not going to change. It's going to be completely ignored by the interpreter. It's just something just for us, right? So that's what comments do. And usually we put a comment at the top of each file with like saying who wrote this code, what is the latest date that they updated, and what this program is about, for example. Now, we use the comments to make the code, like I said, easier to read, to understand, and we'll see, like later on, we'll talk a little bit more about comments and how many we should have in a code. And they are really useful to indicate any other information. Now, what else I want to say? Yeah. Something that I want you to know is that you see this print statement that I wrote in the text file. I can write it in here. But anything that I write in here, say hello everyone. Let's say. Instead. I will see the results right away, but this will never be stored somewhere. So if I close my computer, I will lose these lines. Versus if I write code in here, I'll be able to store it, and I'll be able to close and reopen and reuse it as many times as I want. So the shell is also good. If I want to test something or use it as a calculator very quickly, I can use it. But if I want to store information for your assignments or any practice question, you should write on the text shell. Make sure that you save whatever your instructions, whatever you're writing there. Now, like I said, structure, syntax, and punctuations are very important in Python. And in programming languages, they can be very, very picky, and you have to be very specific. So you see here, for example, the word print, it's color-coded in magenta here, saying like, oh, I know what you're talking about. I know about this print function. But if I change it with the print uppercase P, it doesn't make any sense. You see, like now it's colored in black. Actually, if I try to run my program like this, it's going to give me an error, saying like, I don't recognize a function called print with an uppercase P. The only one that I know is the one with a lowercase p. So I'll have to be very specific. Same thing here. What if I forgot about these parentheses? And I hit play. Same thing. It's going to tell me, oh, I don't get this. This is this like structure. Doesn't make sense. And these kind of messages in red, I know that you might be annoyed whenever you see these messages, but you have to understand. Make sure that you read them. Sometimes they give you hints. They can help you. Or they can just, if you have like hundreds of lines of code and you see this message in red, they can help you locate where the issue from. So you can like debug and make sure to correct your code. So here we will get what we call a syntax error. There's something wrong with the structure, with the syntax of the print function. And like I said, sometimes it tells you missing parentheses. So if I add the parentheses back, and I run it, now it's working fine. So be careful about this. Programming languages can be very picky with the syntax. What else? Oh yeah, something that again I highlight on this is that in your midterm, for example, there will be certain parts where you have to write code from scratch. And like I said, don't forget that you have to write it by hand. I know it's annoying, but that's how it is. But the 2/3 of the question could involve questions of debugging nature. So I can show you a code and tell you, okay, what will happen if I run this code? And you have to tell me, is it going to run okay, or am I going to get an error messages? And sometimes there are some certain categories of errors messages that I wanted to recognize, or error categories that I wanted to recognize. There are 3 of them. And you'll see with time that they're pretty easy to distinguish. The first one is this one. So a syntax error. Anything related to a syntax. So let's say I show you a code like this, and I show you a missing parentheses. You know that if there's something wrong with the syntax, with the structure, it's going to lead to a syntax error. So I can say, okay, if I show you this, what kind of errors I might expect? And you can tell me syntax errors. So these are the kind of questions that you might expect on a midterm you'll be able to recognize. And you, as a coder, you know that when you get a syntax error message, you know how you would solve your problem, okay? So that's why it's important to recognize these messages. So this is the error message. And mistakes happen, and it's part of the learning process to see these messages. I know like a lot of students get annoyed. I do get annoyed with them whenever I program, but it's part of life. Get to learn from them and try to enhance your code as you go. So most of the time you spend on your code will be fixing the mistakes that you make. Usually, sometimes, I don't know, you write your code and say, okay, I know exactly what to do, tack, 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 tack. And then if you run it, you'll see mistakes or something like you are expecting a certain result, you're getting another result wrong. And it's your job, and it's another mechanism to have to learn, is to debug. So everything that you see an error, that's what we call a bug in a computer. And you, as a coder, should be also a debugger and be able to locate where the issue is from and how to correct it. And to learn how to debug is important also to make mistakes on purpose, to see what kind of errors I might get. So for example, if I name, like I said, if I name the print, the word print with an uppercase P, for example, you'll see a name error saying like, I don't recognize the name print. It's not an issue of structure, it's an issue of naming convention. I don't know this print thing with an uppercase P. I only know the one with a lowercase p. And the other one, so these are like the two of the three categories that I wanted to know. The other one is the syntax error, like I said. So you forgot about parentheses, or you closed, or you, yeah. What else I wanted to say? Yeah. So this is one example. So when you write code, sometimes, especially at the beginning, do try make mistakes, like say, oh, and that's the great thing about a course like COM202. You get an automatic feedback. You don't wait for me to give you an answer. Sometimes you say, hey, what if I do this and that? You can try it and see what happens. Maybe it would work, maybe it's not. And you have to understand the mistake. And that's a great way to learn. Now, I want you to create a new program called sum2variables.py. If you don't have a computer, don't worry. I actually don't expect you to have a computer with you during the lecture at least. But take a piece of paper or your tablet and try to write in a file, whatever file, it doesn't have to be, a file, these three instructions. And you might want to have comments. And if you have your computer, you can make mistakes on purpose and see what happens if you run them. Now, yeah, sorry. So let's say I'm gonna do this with you at the same time. Let me create a new file, and I'm gonna call it sum of two variables. All right. So that's the file with the .py. It is given by default because Tanya understands it's all about Python files. So I'm going to define these two variables, a equal to 7, b equal to 3, and c is equal to a plus b. And I would say this program computes the sum of two values, and I'll say date. Okay. So this is comment completely ignored by the interpreter. The interpreter will start looking into lines 3, 4, and 5. Completely ignore the first two. Now, if I run this file, what do you think I'm going to see in the shell? Anybody? Especially someone who never programmed before. If you know the answer to this, yeah.
C equals 7? Or,
C equal 10, you mean?
yeah, sorry, C.
Okay. Yeah, that's what I would assume also. If I run it, but I don't see anything. Why is that?
So pretty.
Exactly. When you, was that your, oh, you have a question? Okay. You have to know that when you writing code, you have to think like as if you are talking to a kid, for example. You have to be very, very specific on what you want. So here, so far, what I'm asking the computer to do is, I want you to define a first variable called a with a value 7, a second one called b with a value 3, and I want you to compute the sum. That's it, and it's going to compute the sum. Did I mention something about displaying this sum? No. You have a question? Okay. Did I say something about displaying the sum? I didn't write any instruction that would say I want you to show me the result, right? And that's why I don't see any result. But the computation is happening. I don't see it because I didn't ask to be shown to me. Now, my question for you is, I will need a print statement to display the value of C. In your opinion, which one of these solutions is or are the correct answers? So far the three first line are just doing the sum. But if I want to display something, I will have to use the function print in order to see the result. Otherwise, it's going to just do the computation and that's it. Now, which one or few options is the correct one?
Right after the summer, during that semester,
Oh, okay, you're not the one. Okay, I thought like you were talking to me in person. Okay, no. Okay. All right, let's take a look. All right, so majority are saying B and C, and let's see. So let's pick option A. If I say print the sum of the two integers is C. It's just going to literally showing me all of these characters. So everything that you put between quotation marks, even double, either double or single quotation marks in a print statement, it's not going like Python. It's not going to say, oh, do you mean the variable C? Let me show you the value of that variable. It's not going to understand this. All it understands is I want you to show me the character uppercase, lowercase c, and the character uppercase t, the character lowercase h, and that's it. It's not going to interpret anything further. So it's just literally showing me this. So if I want to see the value of the variable c, I would have to stop my message, anything between quotation marks to be displayed as it is before the c. I will put a comma saying, hold on, I'm not done with my message. So the comma saying, hold, wait, I'm still saying stuff here. And then I put the word C. And you see, I put the character C without a quotation mark, meaning actually I want to see what's inside this variable. What is the value of this variable? Now, if I run it with this, I'll be able to see the value of C. I'll be able to see 10. Make sense? And other way of using print statement, I can just say print, no quotation mark, and I say print C. So I want you to print the value of C, and that's it. No explanation, nothing, no message. And that's how you will be able to see the number 10. Make sense? Any questions? All right. Well, I'll see you next time. Take care.
Question about the midterm.
Yeah.
So my midterm, I have another midterm, the British midterm, at exactly the same time
Yeah.
as February 27th.
Okay.
So is any possible to do?
So, as I said, like I think you're not the only one.
Yeah.
Next week I will have a quiz on my courses. Just tell me that you have an exam on that day.
Okay.
Show me your proof, and I will make another makeup session. The only thing is that if I make a makeup, that's the only option that you have. Like if you have like another exam during the
Yeah.
time, you have to make
Okay, to the another
check
exam.
with the other.
Okay.
Yeah.
Thank you so
All right. Just 1 second. Sorry, just to write.
I got a friend, like, she just enrolled in the class, but she is added to the wait list. She want to know, like, if she got 17 people ahead of her, is there a chance she might still get into the course?
I have no idea, honestly, but now, like, I'm seeing sometimes, like, people leave, like, 40 and 50, so maybe on the 17th she has a shot.
So for the other section,
She can also try the other section. And
is that more like there's less people in that section?
I honestly don't know.
Oh, okay,
Honestly, I don't know. Yeah. Probably, I mean, she can still attend the lectures if she wants to, but she has to be looking at her email very, because the spots will disappear very fast.
Oh, okay, thank you.
Yeah. You're welcome.
Sorry, someone left these.
You can put them in here, I guess. I see like a few missing stuff. Okay. Thank you for this. Yeah.
Sorry,
Hey.
I'm just wondering, are we sort of allowed to use VS Code?
Yeah, you can. Like I said, you can pick, but it's just like I'll be using Fani during the class. But if you are figuring out stuff with you by yourself in VS Code, it's fine.
How are we submitting like the assignments?
So the assignments are going to be on Ed and it's just copy pasting your code into another place. So don't worry about the ID. It's
Thank you.
welcome. Hey.
Awesome. Could you just highlight the difference between a compiler and an interpreter? Because I'm not really sure I understand.
It depends. Both of them are translating codes. Okay. But for example, it depends on programming languages. Certain programming language will use a compiler. So C++, they will. It's like, let's say you write your code like we did here. If I say print hello world, let's say,
Yes.
and then if I compile it, I will have another file within, like, see earlier I have like hello.py file, let's say. If I compile it, I'll get another file with a .exe extension, and if I try to open the file, I'll see a bunch of zeros and ones. That's what a compiler will do. It will convert it into a bunch of zeros and ones.
Right.
And then I will take that file, click on it, and I will see the result of like the message hello world being displayed. But in Python, you see when you use an interpreter, it will do the same things on the spot. It will translate and show me the result, and that's what the
So
interpreter
it'll
will do.
skip the step where you've got all the binaries.
Exactly. It will do it. It's not going to skip it, but it does it like at the same time on the fly.
So then what is the benefit of a compiler? Like, if the interpreter is just going to show you the final result?
The thing is that when it's usually like in reality in softwares would be written program like C++ that would use a compiler, because once you write your code, you don't need to translate it every time, right? You translate it once, you have that file, and you just need to run it.
Right.
When you have an interpreted language like Python, every time you need to run your code, you have to do both. Translate it and run it. So it will take time.
What's the difference between translating and running it again? I'm not sure. I
Okay,
understood that
so translating is having like whatever I wrote in English will be translated in a bunch of zeros and ones.
Right.
That's the translation. Running it is actually, hi, am I?
I can wait. I just wanted to check if you have a class here.
Yeah, it is. I mean, you can help yourself. You're welcome. The only thing that you need, the trackball, there is no. Yeah, I didn't bring any. Yeah, that's it. But it's working fine from what I.
Ooh, glad to hear. Thanks. And, okay, so from there.
Yeah. So the translation is just what I wrote in English is going to be written in zeros and ones. The running is actually whatever
Right.
instruction I
Okay,
give
that looks good.
is going to show me the result. So if I tell
Right.
the compiler will translate my instructions into the it's not going to translate it like, imagine I'm talking to someone, and that person will say, I don't have time, I don't do anything. Say, go for a walk. The interpreter will tell you, go for a walk. So the interpreter will say the word, and you are going to do the actual walking, right? So the interpreter is just going to translate whatever I'm saying, and you are going to run and follow. That's why I mean by running.
Okay.
Makes sense?
Thank you so much.
You're welcome. Hi.
Hi. Just have a quick question about the flow. I just want to know why you added this part and this stuff.
Because sometimes flowcharts can be too complicated and too big, and I want to know where I should start and where it ends. And that's why I need those to like, okay, because it could be like very messy. So this will help me like locate.
Yeah, okay, I got it. No, can we time to talk outside?
Yes.
Please,